Hello and welcome back everyone to Space Simulation Toolkit, and today we're basically going to simulate the Big Bang. I've tweaked gravity and other settings a little bit to make it easier for objects to form out of nothing, and well, for things to coalesce into larger objects. And we have this amount of material in the center that we're going to start with. What I'm going to do is I'm going to rip this apart by giving it a little bit of a spin. Put a little spin on things, huh? Alright, here we go. The centripetal force should tear this apart. Oh, now that looks cool. That looks really cool. Give a little bit more force so that the old spaghetti noodles get separated out. I'm not sure how mean YouTube compression is going to be to this, so I'm going to try to do a lot of close-up shots as well. As you can see, we already have some things forming all throughout. We got little planetoids forming. We got lots of just space dust all over the place. Lots of space dust everywhere. Little asteroids. And those little bits of space dust, which I guess are more of asteroids considering that there's so few particles in the world that the smallest one would be the equivalent of like an asteroid in the real world. They're starting to collide and merge with these planets which are forming. So I expect that this kind of calm and steady formation of planets is going to continue for a little bit, but let's just keep an eye on it. At some point, though, something's going to happen that's not happening in our universe, which is the big crunch. Right now, basically, this is the expansion after the Big Bang. Everything's getting further apart as time goes on. But gravity is winning out in this simulation, and even though things are spreading out in localized areas, gravity is causing these planets to grow. And grow they will. But as you can see, the rate of expansion of the universe is slowing rather quickly, and at some point it's going to reverse because the gravitational center of this universe is right here smack dab in the center, because that's the average of where all this stuff is, which means it's constantly pulling on everything to go back to the center. And it's going to be quite dramatic when it does happen. As you can see, these planets are just chilling. Some of them may even get their own little asteroids in orbit. Like, oh, did you see that? That asteroid actually hit a moon. The little moon broke it apart. That was pretty dramatic. But yeah, look at this little particle here. Oh, it hit another asteroid again. Oh, look, we're gonna get two planetoids. Oh, those two collided. Now they've formed an even larger. It's more of a planet now. And this is happening all over the place with these millions of particles. The same story is playing out. As these planets continue to grow, they're just pulling more and more in. Like this one is going to pull in this little, is it going to be, oh, yep, ripped it apart. And as they get bigger, the amount of gravitational force they command only increases. So the collisions only get more and more dramatic. Now this guy, who just ate a tiny little moon himself, is about to crash into this much, much larger planet. Oh boy. Oof. That was a huge collision. But now this planet is really big. Actually, I can turn gravity max velocity up as well to let it get a little bit more dramatic. But overall, we can see that these objects are coming together and forming larger and larger pieces and planets, which when I zoom out, that's what's basically visible. All the big pieces become visible, all the small things fade away into obscurity. But look at it grow. Each one is just trying so hard, and so we're going to see where they all end up. These both are going towards this object over here, but they're also going to collide with each other. Well, maybe not. I think that's actually going to dodge it. Oh, no, didn't dodge it. Oh, orbiting? 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 No, I'm barely not orbiting. They kind of just merged. That wasn't very aggressive. That was a very kind and understanding combination there. Ooh, that was a pretty brutal. This one actually flung off some material when it collided. That's what's going to happen as these collisions get larger. They're going to have a little bit more at stake. There's still a lot of particles just in the middle of nowhere that haven't even connected with one other particle. These little ones that have 2 particles about to become 4. Good job. Good job. Clearly did their homework. Bouncing around. On. Here comes another one. Bam. So at this rate, we're seeing a huge consolidation. Oh, look at this one. This one is massive. And most planets now, A, have some sort of rings forming around them, and B, have a spin, because all of the collisions have actually imparted a lot of force, like this one right here, which is going to give it even more of a spin. But these large planets are continuing to attract even larger planets. But if you look, there's some sections of the universe, like over here, that have way denser formations, and that's just how the gravity turned out. I don't think I did any real bias when I started this, but over time, the tiny little biases added up, and ooh, here's a huge one. These 2 very large planets are colliding. They're both trying to exert as much force onto the other, but it looks like one of them won, ripping the other one apart, throwing away what's left. There's just a tiny bit left, but it's going to get more complicated because another planet's coming and it, oh, absolutely obliterated it. I think it probably lost more material than it gained in that collision. Wow. The amount of material ejected from that is actually just completely restarting the formation process in this area. There's so much new material. It's actually kind of clumping together and forming little asteroids. Holy moly, that was crazy. Let's check on one of the other larger planets. Almost as large over here. This is probably the second largest one. It also is trying to consolidate as much material as possible. It's not quite as fast, but it is speeding up. It looks like the results from that explosion, and there's a lot of small protoplanets around this one, so maybe it will actually grow faster because it can pull in these big chunks. As long as they don't shatter the entire thing like last time, it's probably a much faster growth method than the tiny particles. And here we go, another 3, 4, 5, 6. All of these protoplanets are being absorbed into it, one after the other. Ooh, man, they were given life just to be reabsorbed a short week later. Oh man, it is going so oh, crazy. I could also switch the view mode. I wonder what other views. There's spectrum damping energy. There's I can't read that. It looks like it's showing the, when the things hit, you can see the ripples, which is kind of cool. I think it's showing the velocity. I think the color changes depending on the direction it's going in. That's actually really neat. You can actually see which parts of the universe are being attracted to what, because there's a color wheel around the attractor. That's super cool. So like if it's being pulled right, it's red. So to the left of these big objects, there's a bunch of red. Oh wow, that's actually really neat. I should have used this more often. You can really see those shock waves when they travel through as well. Then there's this one, which is kind of like a chiller version, where you can really see the energy moving through when it hits. And then this one's just red. I don't know. I think I may actually leave it on this because it makes it really easy to find where things are happening. And it looks really neat. These are actually moving really quickly. This one has gotten so large that it is just commanding a lot of power over the universe. It's pulling in way further, and once it eats this planet, it's gonna almost be unstoppable. Look at the absolute size of it. And remember, when we started, all the planets were like 1/10 of the size. But there's very few protoplanets left, so the only thing left for the planets to eat are tiny little bits of dust, which are getting quite rare now. I mean, there's still some just out in the middle of nowhere, but if they're far away enough that they haven't been eaten yet, they're moving so slowly that who knows if they'll ever actually be eaten. This circle is shrinking as everything is attracted to each other. But most importantly, these two are very close now. I can feel the... This one hasn't grown much. This used to be like one of the largest. Like, we were looking at this and we're like, whoa, that's huge. But now, this exists, which is much larger and much more terrifying. Oh, here's a big one. Here's a big one. Ooh! Oh! It exploded. It was too much. Whoa! Holy moly. I did not think that was going to happen again. I mean, it's kind of reformed, and I think it's still larger than it was before the explosion, but wow. A lot of new material was just ejected out into the world for the other planets to use. The results from that explosion are actually smacking into this planet. Look at all those. And they're actually, the particles are moving so quickly from that. Oh, look at there's a meteor shower from that. Look at all of it. The things hitting from that direction are getting so deep into the planet as well. They have so much velocity. That is crazy. Oh, and here it is. It's gonna happen at last. Oh, those collided without a huge explosion. They just combined very, very easily, forming a planet just as large as the largest. I think they're about the same size now, but wow, I'm just surprised that that one didn't explode after the first one exploded. So I was like, okay, at that size they explode, but apparently they don't. Well, it happened again because we got a pretty large chunk coming in, and is it gonna cause it to explode? A lot of damage, but not the explosion. Looks like it's stabilized since then, and it is certainly going for lunch. And then, actually, we'll match this to it. There we go. So that's the size of blue. And then if we go over to yellow. Yeah, so technically they actually look to be the same size, but blue is a tiny bit larger than the circle. Yellow is a tiny bit smaller. Also, blue just grew. So this is a pretty even matchup. And wow, after all that time, they are finally going to do it. They're finally going to collide. This is the moment you all have been waiting for. I've been waiting 42 minutes for this. All right, here it goes. Oh, it was too much. They formed a line. Oh no, here it goes. Oh, it's collapsing back inwards. Is it even going to be able to form a stable? Honestly, it just kind of formed its own Big Bang. Look at the physics that are going on here. Look at the physics, the shape. Holy moly! The amount of material this is letting out is insane. This is like half of all of the particles in the simulation and just chucking them out. It really is just like another Big Bang. And I mean, it's going to reconsolidate all of this really quickly because it's close. Oh, this one just exploded too. Huh. Why did they happen at the same time? I wonder if the material from this flew out and hit the other one. It's really odd that it seems like they always do that like explodey thing at the same time. The stability just degrades in the universe until everything goes boom. Oh my god, it's gone. It's completely gone. It just ripped itself to shreds. Maybe it's just a cycle. Maybe it's a cycle that's just never gonna end. Once they get to a certain size, they just cannot handle it anymore. It's trying to reform a stable object here. It's trying very hard. Oh man, the size of that explosion, it lost like all of the progress it had made. All of it. And yeah, it's all like, it's much more concentrated, so it will rebuild pretty quickly. But it's just shocking that after all of that, it just restarted. It is growing pretty quickly though. I think it's actually already at the size of one of those prior to the Great Explosion. And now it's just vacuuming in all the material to regrow to its former height. But like, wow, look at what it left behind. It actually has kickstarted the development of new protoplanets again. Like that. Little atoms are starting to find each other out in the middle of nowhere and are forming cool stuff. Who would have thought? I mean, after you saw it happen multiple times, you may have thought. But yeah, no, it was probably very predictable. But it's still interesting. Things can be predictable and still interesting. Let's see if it happens again. I mean, this is growing incredibly quickly. Will it reach a point where it just explodes? You can see that the outside of the planet has a ton of motion and force because of the things hitting it, but the inside also has a ton of motion and force from it being compressed. And it's getting more and more and more so. Look at the colors deepen as... Oh, and it just took one big collision to set it off. And it happened again, and this time there's nothing left. Last time there was at least a planet left behind. At least something. It just formed like 6. Wow! I did not expect that. So under the current laws of physics, which is interesting, at a certain size, these are no longer stable and they just go supernova, which is kind of realistic. And yes, it'll reform over time, it'll get the material back. Most of the gravity is still in the center of here, so it'll just slowly grab and morph and reform. But it's important to remember that this will probably just keep happening forever. It's just a cycle of these planets and stars forming, merging, and then exploding again. And that, there's something strangely calming about that, you know? It's never over. I could probably leave this running on my computer forever, and things would keep happening. It would keep being interesting. Although, I guess if the same thing is happening over and over and over again, is it really interesting? But you know what I mean. But at least we know the warning sign now. Once we start to see that acceleration, the velocity in the center of the planet, we know that it's about to go boom. Or when it gets hit by something massive. Nope, see, that didn't trigger it. It has to hit a certain mass. So this is honestly super interesting. That's why I keep saying it's super interesting and keep letting the simulation go, even though it's been running forever. It's I'm curious if it'll happen at like the same point again. I'm curious what causes this behavior. It's growing again. It's growing again. It's growing again incredibly quickly, and boom. Okay, that was a big enough collision for it to get kind of destroyed. It's reforming, though. It's reforming very quickly from that. It wasn't quite as dramatic. These other planets have just kind of stopped. They aren't really doing anything anymore. Alright, after all this time, I am finally going to interact with the simulation to try to tie up loose ends. I'm going to move the stuff far away, closer. Significantly closer. Because my intent is to get it to collapse back in on itself and do another big bang. I don't know if it will be able to do it with all the material, but I'm gonna give it a good shot at it. I'll make it more possible than it was 2 seconds ago. I'm just helping to crunch everything back in. Alright, it's big crunch time. Oh, yeah, it just exploded. Again. And when they explode, they form these really cool nebulas. But yeah, it would appear that there is no way to, with the current laws of physics, get it to all consolidate to one spot. That makes it very unhappy. But I'm still gonna try. I'm gonna put all of the material towards the center, and I'm gonna try to get it as stable as physically possible by just manually overriding, manually mixing it, and getting rid of the movement force every time that it tries to explode. Yeah, no, it legitimately just, at this point, it just wants to supernova. There's nothing else it wants to do. It wants to restart the universe. You know, who am I to tell it no? Who am I to tell it no? And yeah, just like it started at the very beginning of this video, it goes all over again. Very poetic. Very poetic. Bottom text.